Hello and welcome back to Learn Python, your first step to data science. In this new chapter, we're going to look at classifying wine types. And in particular, in this video, we're going to look at importing the wine classification datasets and visualizing its characteristics. Let's dive right in. So if we go back to chapter 5, in the chapter 5 IPYNB, which is the chapter 5 Jupyter Notebook file, in the accompanying code files that you guys have received alongside the course. If we open this Jupyter Notebook, we can see the following. In in1, we first take a function from the datasets module in scikit-learn called load wine. And this function allows us to load our wine data that we're focusing on in this particular video. After we've imported this function, we can move on to in2. In in2, we assign the load wine's results into wine data, which is a variable that holds our wine datasets. So that's in2. In in3, we call the directory function, the dir function, to investigate what the wine data object holds. If we look at the wine data object, we can see that there are 5 attributes. Number 1, the description of the wine data. Number 2, the inputs or the data portion of the wine data. Number 3, the feature names, which is the column labels we can use to label the data part of the datasets. The target, which are numeric representations of different classes of wine that we want to predict. And target names, which are corresponding to what numbers in target corresponds to what actual wine names we're looking at. So that's the directory of wine data in in3. In in4, we're printing out the description of wine data. So this is a wine data database. The dataset characteristics are there are 178 instances with at least 50 in each 3 classes. If I was a data scientist, I'm going to first investigate why there are 3 classes with 50 instances each, but in total there are 178 data points. Does this mean that 28 data points are invalid? Are they empty? Do they have missing data? All of these things are good ways to start investigating whenever there are incoherent informations like this. The number of attributes is 13. We have 13 numeric predictive attributes. So if we look at the attribute information, we have the alcohol, the malic acid level, ash, alkalinity of ash, magnesium, total phenols, flavonoids, non-flavonoid phenols, and other chemical measurements of the wines. Like any good dataset, it is showing us the summary statistics of these columns. We can see that the minimum, the maximum, the mean, and the standard deviation of these features don't align, which tells us that we haven't been handed a standardized dataset, and standardizing the features may help us boost our performance in our classification projects. We can see that there are no missing attribute values, and actually now the class distribution question has been answered. You can see here that class 0 has 59 instances, class 1 has 71 instances, and class 2 has 48 instances. In in5, we take the wine data property and assign this value to the variable called inputs to make it more clear what we're dealing with. In in6, we're taking the target property of wine data and we're assigning the value into outputs as a variable to keep it simple. In in7, we look at the shape of inputs. As we expect, there are 178 instances and 13 features available for us to use to predict the class. In In8, we look at the shape of the output, and as we expect, there are 178 class labels for us to predict. In In10, we look at the wine data's feature names, and we can see that it corresponds in a programming-friendly way to the descriptions that we've just saw. In In12, we import the data science package pandas as PD, as per data science community's shorthand. In In13, we create a new data frame, a new pandas data frame, consisting of the input data with the column names named as winedata.featurenames. In In14, we first create a pandas data frame over the output data, and we concatenate it with the original DF along the first axis, which is the column. In In15, we see that most of the features are distributed close to each other, although their magnitudes and their absolute values are located in different regions of the real number line. And if we describe this, we can see summary statistics in In16, where counts, the average, standard deviation, the minimum, the quartiles, and the maximum are shown for each of the features. All of these are very important information for us to understand how we can predict the class correctly later. To make the table better, we're using the style property of the data frame and passing in a format call. In this format call, we're making every number formatted to 5 decimal places after the decimal place. We can see that this gives us a much better overview of the summary statistics on this dataset. In In18, we want to visualize the correlations between different features to see whether there are patterns. We first import from matplotlib, which is a mathematical plotting library in Python. We're importing the submodule pyplot, Python plotting, as PLT, as per the convention. We use the matrix show function in PLT in the second line to show the correlation matrix of the data frame DF. We set the X tick marks and the Y tick marks according to the column names of DF, and we'll create a new color bar in the plots. Let us now look at the plot. We can see that there are multiple things that are very negatively correlated with each other, for example, total phenols and the output, or the proline levels and the output. There aren't a lot of very positively correlated items, perhaps except between some of the features, but nothing is strongly positively correlated with the output. Instead, there are some features like total phenols that are strongly negatively correlated with the output.